Okay, I'm back, and we just got through with Bowen's reaction series, and you'll notice that quartz is at one end of the reaction series, and then notice that quartz is at the other end, it's at the other extreme. So let's make a comparison of the difference between olivine and quartz. And then all of these other minerals would be in between these two extremes. So that olivine is very stable under very high temperatures. So olivine likes high temperatures. That's why you find a lot of olivine in the mantle of the earth, where it's very hot. But quartz is stable under low temperatures. So that's why you find sand on a beach. So sand is made of quartz, and it is very stable under surface pressures and temperatures. Olivine is the first mineral to crystallize from a magma, and quartz is going to be the last one to crystallize. So that means that if you take a material that has quartz and olivine in it, which is not very likely, but let's say that you've got something that has both quartz and olivine, and you start to heat them up, then you notice that quartz will be the first mineral to begin to melt. It melts at very low temperatures, whereas olivine would be the last mineral to melt. Olivine it's very low in silica. So now they're both made, quartz and olivine are made of silica tetrahedrons, but the amount or the percentage of silica tetrahedrons is different in the different minerals. So that olivine has the least amount of silica in it, and quartz has the most amount of silica. This is going to be very important because the amount of silica is going to determine how viscous the magma is going to be. And so stuff that has olivine in it is going to be very runny. On the other hand, things that have lots of quartz in it is going to be very sticky. And then that's going to affect the kind of volcano that you're going to end up with. Okay, olivine has a very simple structure because it's only composed of silica tetrahedrons that are glued together with an ion, a positive ion in between. On the other hand, quartz has a very complicated structure because you've got all of these silica tetrahedrons that are glued to each other, and again, that's going to cause it to be very sticky. It's going to cause it to be very viscous. It's not going to be very runny when it's a magma. Okay, then another thing about olivine, it's dark in color, and quartz is light in color. So if you look at an igneous rock and it's dark, chances are it doesn't have a lot of quartz in it. Then olivine tends to make ultramafic rocks, and rocks that have the mineral quartz in them tend to make very felsic rocks. So just keep that in mind as we start to discuss different kinds of magmas and the kinds of features that they make. All right, let's take a break, and we're now ready to start talking about igneous rocks.